Hey, good morning. Slightly lower attendance. I suspect attendance will, drop down and tail off as people start to feel comfortable that they're picking things up or not picking things up from the online material, and that's fine. If you aren't coming to live lectures though, and you're getting confused, just remember maybe you should go back to the live lectures. And of course, always reach out for help. All right, so where are we here? We are in week 5, talking about objects and classes. And I'm going to talk a little bit about inheritance, but really talk more about inheritance and polymorphism next week. And that gets also into design of code, design of software. And then after that, we start talking about Java FX stuff. And so that's where we are. That's the plan. We'll do this lecture Monday, Wednesday, and then as usual on Friday, have a discussion about the project, and I'll go over the examples that I gave you in terms of the P2 deliverable, and talk about, not just show you, hey, this is a good one, this is a bad one, but why is it good, why is it bad, and give you tips on how you can construct sentences that actually provide information. So let's see, what's due this week? Homework 3 due this Friday, and then project 2 deliverables due the following Monday. So it's starting to, you'll want to work on that early in the week, one of those two, to get them out of the way so they don't pile up on you at the end. And the project 2 stuff, the P2 deliverable is remember, it's the description of the functionality of the software. It's not a description of how you achieve that functionality. All right, where do I need to be here? I need to be on my notes. Let's see, what do my notes say? As usual, outcomes at the end of the week. Convince yourself you have these outcomes achieved. You'll really know when you're doing your project if you've got these things, okay? So remember this stuff. We know this stuff by now, right? An object is a set of attributes and methods. Attributes describe the state of the object. The methods alter the attribute values. That's another way of saying that the methods alter the state of the object. We also know that a class is a design and the object is an instance of the class. The object is the actual thing. The class is the design of the thing, and that you don't actually have an object until you do the new keyword. How can you think of an object? It's easiest to think of an object as a physical component. So when I threw up that first example of sheep-sheepdog game, one of the reasons I like that example is it's really clear. To play that game, you need a dog. Okay, that's an object. You need sheep. That's an object. You need terrain. That's an object. It is a little tougher as you start to move up into abstraction to think about what those objects might be. So now, instead of a physical component, what if I have a system? I never can think of a good example for this. What if I have a system, for like the school registration system, when I have student advisees, I can go to the Campus Solutions and I can find out what classes they're currently taking. I can find out what classes they have put in their shopping cart for next semester. I can find out what classes they need to complete their degree requirements. Those are 3 separate pieces of functionality. So you can break your problem up into, okay, what kinds of things can people do? And each one of those might be an object. There might be an object just to figure out what classes you're taking now and tell me. There might be an object to figure out what classes you need to take to graduate and tell me. So in that case, you have a complex system that can do different tasks. And instead of having a physical correlation to an object, you can have a process version of that. Something that performs a task. If you have a bunch of objects, you may also have some kind of a manager or a controller that's directing all the action. So in the sheep-sheepdog game, you'll see not only do I have the dog and the sheep and the terrain, I would have also a controller class that runs the game. That's not always the best way to do things, but that can be done. You can think of it as a service provider. What services do I want to provide to my customer? What services does this object need to give to other objects? And then more than that, and more abstract, is thinking of it as a process. So for example, you're making the Run Away from Zombie game, and you want to make sure that zombies can't go through walls, so you do collision detection with walls. That could be its own class. It's performing a specific role in the game. You can say, okay, I'm going to have a collision detection class. That's its job. I feed it some information and it tells me if things collided. Remember, the heart of the object-oriented paradigm is that we don't view computation as a top-down, do this line of code, do the next, do the next, do the next, do the next. We view computation as this interaction between the objects. So now the sheep-sheepdog game, that's the interaction between the game controller, the dog object, the sheep objects, the terrain object. Those software objects are going to be reporting information back and forth to each other. Hey, did the sheep run off the field? I don't know, let's ask the terrain object where the field is. And then we'll know. Let's ask the sheep where they are, then we'll know. So those are all different ways about thinking about what an object is or when you might need to create an object. And the way you get good at it is you do it, 1,000 times. You get good at writing code by writing code. What I'd like to talk about next, though, is, and I've been ducking this issue, is what happens in memory. So the way Java programs run specifically, now this is just for Java specifically, Java has something called the JRE, or the Java Runtime Environment. You may have noticed that when you downloaded things, you had to download the JDK, the Java Development Kit. And part of that was the JRE, which was the Java Runtime Environment. So half of that is about creating programs and compiling them, and then the other half is about actually executing them. And what the Java Runtime Environment does is it has something called the Java Virtual Machine. Why do they have a virtual machine? Well, let's see. Those of you that programmed in C and came from the C class, you know that you compiled your programs and you got a .exe, which was an executable, and the computer could run the executable files directly. And if you took your .exe and you just copied it over to another computer, there was a fair chance that it wouldn't run. Certainly if you copied over from a Windows machine to a Mac machine, or to a Windows machine to a Unix or Linux machine, it wouldn't run. And the Java people wanted their programs to be portable. So what they did is put an intermediary layer between you and the physical machine and put a virtual machine in there. So what happens is Java has created for Apple, Windows, Linux, Unix, other operating systems, a virtual machine that will work with that operating system. So we're going to talk in terms of what the Java virtual machine is doing. When you're running your code, it's actually running through this JVM. And what does it do? Well, it has to keep track of these objects that you're creating. So when you create an object, and remember, an object has attributes, it has to set up memory space for those attributes. So the JVM, when you say, give me new something, new object, the JVM will say, okay, and let me see what those attributes are. Okay, you've got these 6 attributes. I'm going to reserve these 6 memory spaces for you. Once you've done that, though, you've got to be able to access that memory. So the name of the object gets tagged with the handle, or the pointer if you want. We don't like to say pointer with Java, but I do. The handle to the object. So now I say, okay, I've got these 6 memory spaces reserved for your attributes, and here's where they are. And that's really the only value that's associated with the object name. Here's where your object is in memory. And that becomes a good thing, but you have to understand how that works in order for it to be a good thing. That's why I'm going to talk about memory allocation for a good hunk of this lecture. Now, every single object you create has to be able to have its own attributes, because every object you create will be in a different state. I mean, the simplest example of that is if I create 3 sheep, they all have to have their own unique X location, Y location. They can't all be at the same place at the same time. So they have to have their own unique attributes. So if I create sheep 1, there's going to be, okay, the machine, the Java virtual machine says, okay, I'm going to put you aside some memory for sheep number 1. And then when I say sheep number 2, it says, okay, I'm going to put aside memory for sheep number 2. So it's going to duplicate those attribute spaces in memory in different parts of memory. How do I know if I'm pointing to sheep 1 or sheep 2? When I say sheep 1, the machine knows which memory hunk to go to by the handle. You don't have to do that for the methods, though. All 3 sheep have exactly the same methods, so the machine will only create 1 copy of the methods, not 3. When you're declaring an object, when you say, okay, sheep 1, all you're doing is saving space for the handle. But once you say sheep 1 equals new sheep, right? Once you actually create the object, that's when you get the memory set up for the attributes. The fact that the name of the object is really just the handle for the object means that we can pass that handle around and have other things pointing to that same memory space or having access to that same memory space. And I'll have an example in just a minute. So let me go through the example, and then if you have questions along the way, ask them. But I'm not going to pause for questions yet, because what I just said probably doesn't make sense until you see an example worked out. I wrote this absolutely useless piece of code, which I didn't even bother compiling. If we have this class foo, and foo has 3 attributes, x, y, and z, and I'm not showing any methods. I just care about x, y, and z. And then in another class, we have a whole completely different class that actually uses foo. So it declares object 1, object 2, object 3 of type foo, and then it actually creates them. So let's walk through how that would work. So here's the class foo. It has integers x, y, z, and we're going to walk through this other class that actually constructs those objects of class foo. So we didn't do anything yet, right? So the memory's empty. Then I have that first line of code. Oh, okay, foo, object 1, object 2, object 3. And in memory, all they do is they set up the spaces for the handles. They don't set up x, y, z yet because we haven't made any objects yet. Just, okay, great. You told me you're going to make an object of these someday. I'll save a space for the handle. And then as soon as I say, object 1 equals new foo, now I've got memory set up for x, y, z for object 1. And that arrow over there is showing that we have a handle to that memory. I'm going to basically point to or have access to that memory. So whenever I say object 1 something, it's that specific hunk of memory. So if I say object 1.x equals 42, which we should never do, by the way, we should always use the setter getter. Oh, plus I made x private, so it can't happen that way, right? So we should never do that, but it's just for simplicity, I'm doing it that way. Object 1.x equals 42, that puts the value 42 in that specific x location. And then when I say, oh, I'm going to make another object, object 2 equals a new object, I get a new hunk of memory space. And then I say object 2.x equals 54, it puts 54 inside that memory block. Now hopefully you can see why we're using this dot notation. If I just said that, this isn't going to work. If I just said that x equals 54, how would the Java virtual machine know what x I'm talking about? Is that object 1, the x for object 1, or the x for object 2? Well, I'm telling it. Object 2.x, that specific x value. And that's why we use this dot notation. It's that specific object dot attribute, that specific object dot method. And almost always it's a method because you should make your attributes private. I'm violating that rule for the sake of showing how memory works here. Okay. Now we say object 3 equals object 1. Now there's two ways you could guess at what's going to happen here. One would be to say that we create a copy of object 1 and that becomes object 3. But the other way is to say, or is to remember that object 3 is a handle and object 1 is a handle. So how do you interpret that? The handle for object 3 is the same as the handle for object 1. And I'm trying to show that on the right-hand side. Those two arrows point to the same physical memory space. So now when I say object 3 is equal to 10, it's that particular memory space that happens to be pointed to by object 3 or object 1. In other words, we could use object 1.x or object 3.x and we're talking to the same physical memory space. This becomes very useful when you want to pass objects in and out of methods. So even though I said object 3.x equals 10, when I print out object 1.x, I'm going to get 10. And that may seem weird when you're looking at code, but if you look at the diagram of how the memory works, hopefully that's really clear. Object 3 is pointing to some specific memory space. Object 3 is pointing to that memory space. And object 1 is pointing to the same memory space. So when I say object 3.x equals 10 and then print out object 1.x, I'm actually talking about the same physical x in memory. Then I can do this trick, object 2 equals object 1, and now everybody points to object 1's memory space. Everybody points to the same memory space. And nobody's pointing to this old memory space here. What this stuff down here, nobody's pointing to it anymore. No one's got the handle to that anymore. What happens to it? It's gone. You can never get it back. And the Java virtual machine actually has something called a garbage collector, and periodically the garbage collector goes through and tries to find memory like that no longer has any references to it and frees up that memory so it can be reused. It's garbage now. And I can do this. So remember I said earlier, object 1 equals new foo, and I got that memory space. And if even though I already have an object 1, if I say object 1 equals new foo, the machine does just what you tell it to do. Okay, great, I'm going to give you a new object. A new object means new memory space, and I'm going to give the handle to that new memory space to object 1. So it's good to know that this is how things work, because I often get students doing their projects and they're confused. They're getting weird error messages, or they thought that they had changed a value in an object and they didn't. And it's because they're not clear on how the memory space is reacting to the program instructions. And so they think that they're changing something up in object 1 and they're really changing it in object 2, or they think that they thought that object 1 and object 2 were separate from each other, and the way they set it up, they weren't. So this is I think, a good introduction to how the memory actually addresses these things. And when we talk about passing objects in and out of methods, then it hopefully becomes clear, because what happens when you pass an object into a method is you're really passing the handle in, and now that method has access to that data. When you return an object, so sometimes it's a good idea to actually build a method that creates the object, and when you return the value back, you're returning the handle back. So this is where I should pause for questions. Do we have questions? We should have questions. Okay, charging on then. Relationships between objects. Now, since this is how objects work, what are the relationship between objects? There's two biggies, the has-a and the is-a, and then everything else is association. And association just means objects are associated with each other. At some point, one object requested information from another, or something like that. But the has-a relationship and the is-a relationship. The has a relationship is where one object contains or has another object. We have done this where, oh shoot, let me see here. Random data and random data controller. Okay, so here's random data controller. Remember I had a random data object, right? From last week. And then I had random data controller, and what did it do? It said random data, my data equals new random data. Oh, so the random data controller it contains an object of the class random data called my data. And even within random data, we've built an array, right? That's an object. An array is an object. So random data has an array of integer. This is the has a relationship where one object creates an object of another class. Very common. You'll almost certainly do this because of you have to build objects somewhere. So whatever is your main class, your top level class that kicks off your program, it's got to build some objects, and they may build others, and those may build others, and so on. The other is the is a relationship, and we've talked a fair amount about this with inheritance, and we're going to get into more details next week. I have some examples here where we talk about. No, we may bleed over into next week this week, but we talk about what the inheritance means in more detail. And like I said, association is everything else. So the has a relationship. So basically every program has this, every non-trivial program will, because whatever your top level file is, or whatever the one that initiates everything that has main in it, almost certainly will be creating other objects. You can nest this. So in this case, in the case we had before, I had a random data controller that contained or has a random data object, and the random data object has a array object. So you get like the Russian boxes, right? The Russian nesting dolls, one inside the other. And you can keep doing that for as long as you need to. Now, for your projects, you probably won't need that much, but you can have, again, in a large complex system, you may have, oh wait, this thing has a. An easy way to think of that is in terms of subsystems. So if we think of, oh, how do you build a aircraft? Oh, you've got a fuselage system, and then you've got a fuel subsystem, and you've got an avionics subsystem, and you've got a propulsion subsystem. So the plane has all of those things. Well, inside the propulsion system, you've got a fuel subsystem, and you've got an engine component, at least one. You've got probably some kind of a status indicator system that tells you the health of the propulsion system. So that goes down, and then each of those gets broken down. So in large complex systems, you can have these nesting go very deep. For this class, probably not so much. One interesting thing, objects can contain themselves. Public class foo. Inside of foo, I have public static void main, foo object 1 equals new foo. Not a great thing to do, but why would I do that? Oh, I keep telling you to make all your methods non-static. The only static method you should have is main. What if you want to actually use some of the methods in foo, and main is actually inside of foo? Well, make an object of foo, and then you can use the methods. I've come to think of main as something that you can envision as being external to every object. It happens to be in foo, but in terms of the effect it has on the program, it's as if it was separate in its own separate class. That way I resolve the inner conflict I have of a class containing itself. Not a bad way to think of main. Now, if you have objects that contain each other in this nested form, and for example, again, this is just useless code I wrote for an example. I've got this class top, I've got middle, I've got bottom, and top contains an object of the class middle, middle contains an object of the class bottom, and this time I kept my, bottom has only one thing and one attribute, it's integer x, it's private. So how do you get access to it? You actually set x, right? Use your setters and getters. So you could do this, object m dot object b dot set x. Well, object m is this guy, and then it contains an object b. So if object n has an object b, I can reference it. Object m dot object b. Object b has a method called set x. I call set x. You can do that, but don't do that. My recommendation is you only talk to the object that's, quote, next door. Only the ones that you directly contain. And the reason is, again, this is about code understanding, code maintenance, smoother code design, where if you have an error somewhere or if you make a modification somewhere, what you don't want is if I make a modification in one class, I have to go back and change a bunch of other classes. Oh, and now that I've changed those, I have to change the other classes that contain them. You know, that's the whole thing called spaghetti code, right? Spaghetti code is where you make a change somewhere, and because all of your code is intertwined, you have to go root out how that change is going to affect everybody else, because everybody's talking to everybody else in an unclean, disorganized way. The object-oriented paradigm gives you a beautiful mechanism to not have to do that. Remember how I said think of an object as a service provider? If you think of an object as a service provider, then it provides the service, but nobody knows how it does it because it's internal to the object. It's inside the object. And that's a great way to design your software. The external objects shouldn't care how the object did its job. They're going to ask it to do a job, and then the job gets done, and they don't care how it gets done. So if I say here in middle, I might say, okay, object B, set your X attribute. Okay, great, do it. And I shouldn't care how that happens. I should care that it's correct. I should care that it's functionally correct, but I don't care how it happens. So for example, we're going to deal with geometric shapes for our examples this week and next week. If you deal with geometric shapes and you say calculate your perimeter, I shouldn't have to worry about how you did it. You know, you and I know as human beings that calculating the perimeter for a circle is different from a square, is different from a triangle. But if it's a service provider as an external object, why should I care about that? If it's that object's job to calculate its own perimeter, I have to trust that it did its job correctly, and I don't need to worry about how it happened. Well, the reason that's a good thing is I can change how I calculate the perimeter inside that object, and it has absolutely no bearing on the external object. Now, when you're doing this, object m.object b.setX, you're violating that rule. Because what really should happen, since top is the one that has middle in it, what it should do is, hey, middle, set that object you own, set its value to set X. And I don't care how you do it. You're kind of violating that rule here if you go through that. I don't even know if object middle has an object B. It does, right? Object B. But what if I change the name of that? Now object m.object b.setX won't work because there is no object B. I shouldn't have that. It should be something like object n, do something. And then object m worries about how it happens. So a different way to do that is like this. You say object m set bottom x. Oh, okay. That means that I have a brand new method, public void set bottom x in new. And all it does is it takes in the value that I gave it, 15, and it passes it along to the set x. Now that seems like an extra layer. It seems like extra work. It is a little bit of extra layer and extra work. But as long as this set bottom X method exists, then I can change what it does. I can change how it does it, and it won't affect the top class. Or I could even change what's happening in bottom, and it won't affect the top class. So what I'm doing is getting rid of that, getting rid of these dependencies, getting rid of the spaghetti code. So I'm recommending that that's how you pull that off. And then hold it, let me pause here for questions. I'm pausing for questions. When you're doing your project, you can informally do these code metrics. You know, you can ask yourself, I have an object, how many other objects does it talk to? I have an object, does it always talk to the neighbor next door? Or does it actually talk to, you know, 2 doors down the block or 3 doors down the block? If you know that you're always talking next door, that's great. That's a sign that you're developing good code. And it may be a little more work initially to set up these extra methods, but it pays off. Even within the project, because you know you're going to rewrite as part of your project. You're going to change your mind on how you're going to do something, and if you change your mind on how one method does something, you really want it just to affect that method. None of the other methods should need to be changed. This is that whole idea of encapsulating things. Yeah, there was something else and now it's gone. Okay, I wanted to talk about arrays of objects. You can have arrays of objects, but we talked about this a little bit last week, but now that we're talking about objects, let me go through and be very explicit about it. When you create an array of objects, what you're creating is the capability to have a bunch of objects, but you didn't actually create the individual objects themselves. So here, private double, I'm going to run away from zombie games. I need a whole bunch of zombies to run away from. So my zombies here have X location, Y location, and probably a bunch of other stuff that I don't care about right now, but they definitely have location. And then I've got my zombie controller, and it creates an array of zombies. Now right here, what did it do? Did it actually create the array, or did it just create the handle for the array?
Just the handle, right?
Just the handle, right. Just the handle. We have not created the array yet. The array happens here, zombies equals new zombie 100. Okay, now I've got an array of, now I have to be careful how I say this. I have an array capable of holding 100 zombies, but I still don't have a single zombie yet. Because how do I know I'm going to get a zombie? Something equals new zombie. That's how I know. So what I've got here is an array capable of holding zombies, but no zombies yet. What do I have to do? I have to initialize that array. I have to populate that array with the zombies. So I go through a loop like we always do, and I say zombies I, the ith zombie, equals new zombie. Now I've actually built a zombie and put it in the ith location. So the first time through I equals 0, so the 0th location actually has a zombie in it. And then I can set X and Y, and basically all I'm doing here is initializing that individual zombie. So I'm going to have, in this case, I just set X location to I and Y location to 0. I'm lining all the zombies up on the X axis. That's all I'm doing. But you have to go through and do this. And this is why what I'm trying to do is prevent you from having a null pointer exception. Hey, I created an array of zombies, and now I try to make the ith zombie move, and it says null pointer exception. Well, that's right, because you created the array of zombies, meaning you created all of the parking spaces for the zombies, but you didn't actually put a zombie in the parking space. You didn't do that until you get here. It's similar to, it's not a contradiction from how Java handles other arrays. When we said we created an array of integers, as soon as we created the array of integers, what did it do? It filled all the integer values with 0. So here what we did is we created an array of zombies. That's really an array of zombie handles. And what's the default value for a handle? Null. So when I say zombies equals new zombie, it's creating an array of zombie handles, and then I have to actually go in here and create the zombies themselves. By the way, I don't talk about array lists much in this class, but if you're going to use arrays of objects, some people prefer to use the array list for objects, for arrays of objects. It operates slightly differently than an array, but it's an easy enough thing to get used to. Your text has it, and I'm sure Tutorials Point and W3 Schools has it, and of course Oracle Help has it. I only mention that because I see a number of students using those in their projects. That number being non-zero. Okay, then I'll just talk about the is-a relationship a little bit. And then we'll discuss this more. I think what I'll do is on Wednesday actually go through what would normally have been next week's talk and talk about the is-a relationship a lot more on Wednesday. So this is where our inheritance is, and we've talked about inheritance before, but now we're going to talk about it in a little bit more detail. You use the keyword extends. So you have a generic shape, and then you can extend that, and that's what I'm going to use for our example, is a generic shape, and then you can extend that. Okay, a circle is a shape, a square is a shape, a rectangle is a shape. When do you use these? When you have similar objects that are different in their behavior. That's a hard thing to sell. I mean, because what people aren't hearing is the difference in behavior. Let me give you a really good idea, or a really good way for you to judge for yourself if you need inheritance. I've got two different objects that are very similar in my software. They do different behavior because one goes fast and one goes slow. So how am I going to make that different behavior show up? I'm going to change the attribute value. I'm going to give one a really low max speed and one a really high max speed. If you're doing that, you do not have inheritance. If you're getting what you're calling different behavior just by changing the attribute values, it's not inheritance, and it's not a good, there's no good justification for inheritance. I mean actually different behavior. So if you have in my case, I'm thinking in terms of two-dimensional games where you have movement, and they all have the same movement method, but the movement methods are different. I have to actually change the code of the method for movement. That's how you know you got inheritance. If you're not changing any methods, then you really can't make a good case for inheritance. I'll give you the perfect example. I'm not allowing students to do chess games because we've had some unfortunate incidents with chess games, but chess is a perfect example. You've got this generic thing called a piece, and it has a location, a board location, and then it has movement. And it also could have capture, which is a different form of movement for some pieces. So we have all the same attributes. All the pieces have the same attributes, all location. And then we have movement. And then clearly in a chess game, the movement of the pieces is radically different. So when I'm writing the move for a pawn, and I'm writing the move for a queen, and I'm writing the move for a king, they're radically different methods. That's how you know that you need inheritance, or that you've got a good case for inheritance on your hand. If you're just changing attribute values, not a good case. Now this can be nested, and I'm doing just, again, silly classes. So public class phi, and then public class phi extends phi, and then we can do that again. Pho extends phi, and phum extends pho. Oh, okay. It's an is-a relationship. Phi is a phi. It's a weird, I shouldn't have used these, because when I start to say them, the bad effect. But again, think of what the goal is. You have a generic thing, and then you have a more specific thing. You have reptiles, vertebrates. I have a class of animals, vertebrae, and then I have mammals, and then I have reptiles, and then I have something else. Okay, but a mammal is a vertebrae, and then under mammals I have whales and what else? Possum, not possum, sheep. Oh, okay, a whale is a mammal. A sheep is a mammal. And because a mammal is a vertebrate, a whale is also a vertebrate. So if you think of it, it's not a bad idea to think of the animal kingdom kind of tree structure or any organizational structure to remind yourself of this. And the reason it's going to become important is because that's going to help us write more efficient code. If I wrote code, let's say I write all my code for the sheep-sheepdog game, I write my top-level controller code where all it does is it controls the sheep and then it controls the dog separately. What I really want to do is I'm going to have a generic animal, and then I extend that to the sheep, I extend that to the dog, and I should write my code one time for animal. And then because a dog is an animal and because a sheep is an animal, all my type classes, all my type checking will work out. And then since I wrote it for animal, I don't care how it did its job. Again, so you notice that encapsulation. I don't care how it did its job. That's that animal's job to figure out. So I can say at the controller, at the game controller level, move all animals. And I can go through my array of animals one at a time and move them. And they know how they move. I don't care. That would be different if I had to say, move all the sheep and move all the dogs, or, if I had, I don't know, for a different game, I might have, what do we got? Zombies, werewolves, and vampires. I don't know. And they're all different. So I was like, move all the zombies, move all the werewolves, move all the vampires. No, just move everybody. And the fact that let's have a generic monster, right? So the fact that a vampire is a generic, right? This is the is a relationship. The fact that the vampire is a monster, the werewolf is a monster, the zombie is a monster, then I can write my top level code at the monster level and say, just move the monsters. And all my typing works out. So now I don't have to do special purpose code. I don't have to do things like, if let's do attack. These things get close to a human and they attack. And I have to say, okay, we're going to do the attack. If the monster is a vampire, do this. If the monster is a werewolf, do that. If the monster is a, what was the other thing? Wolfman, a zombie, do that. I don't have to do that at all. I just have to say, monster attack. And then at the individual class level, they know how to do that. I don't have to do a whole bunch of if this, if that at the top level. It's one of the best parts of this object-oriented paradigm, because if I write it so that the code works for monsters, the vampire is a monster, it'll work. The werewolf is a monster, it'll work. I know these are silly examples, but I want to go through these more intuitive examples before we talk about the code itself. But that's a great advantage of the object-oriented system with inheritance, because you don't have to write all this special purpose, these horrible if-then-else structures. Okay, that's all I have for today. We'll go through some code on Wednesday. We have time for questions, though.
So I kind of have a question kind of specific to my project. Is it okay if I just stay after a little bit?
A very little bit, yes, that's okay, yeah.
Okay.
I'm going to stop sharing, hold on. And the reason I say, unfortunately, a little bit is I already have a 12 o'clock meeting. We can also set up, you can also message me in Canvas too, and if we don't resolve it here. Let's see, I'm going to stop sharing. And I'm going to stop recording.